Worth Carnahan's Divided Garden. Today, Worth Carnahan is almost entirely forgotten. But back in the golden age of comics, he did some interesting work as an artist and as a publisher. And among the other things he was involved with, he did some puzzle pages that I'm very fond of. They were clever and well drawn and lots of fun. For example, here's a puzzle from one of these early comic books called The Divided Garden. We have two men arguing over a garden with 6 plants. 2 single bloom flowers, 2 double bloom flowers, and 2 small trees. Now, the problem is to divide up the garden so that each man gets one of each of the 3 types of plants. In other words, 1 tree, 1 2-bloom flower, 1 1-bloom flower. And that the garden be divided into 2 pieces that are the same size and shape. That's the part that makes it tricky. You could probably see right now how to divide it up if you didn't have to make it the same size and shape. But let's think about how to do it and meet this other condition. First of all, just take a look at the puzzle there. Look at the arrangements of pieces. Probably the answer is not obvious to you. So what we're going to need to do is step back and think about it piece by piece to use our problem-solving skills on it. So for instance, let's start by asking ourselves, are there any spots where we know there has to be a fence? Well, yeah, I mean, we know that one piece has to have 1 tree and one piece has to have another tree. One piece has to have one of the double flowers and the other piece has to have the other double bloom flower. Same way with the single bloom flowers. So between each pair of plants, there has to be a fence. Now, we don't know for sure, but we can be pretty sure that there's going to be another piece connecting the piece dividing the trees and the piece dividing the 2 bloom flowers. Okay, that gives us something useful to start with. Now, let's think about what it means to be the same size and shape. All right, well, one of the ways that mathematicians like to talk about this is in terms of something called transformations. That's changes we can make. So if we can make one shape line up to another by changing it, by moving it, or by flipping it like a mirror image, or by rotating it. Let's think about this one here. What we'd want is something where we could change this shape so that the pieces would line up after we change them, after we rotate them or flip them or whatever. So probably that means that when we change our shape, move it or flip it or rotate it, the piece of fence between the 2 trees will line up with the piece of fence between the 2 single bloom flowers. Now, you might want to pause the tape for a minute and think about what we just said here. But if you got it, let's think about, well, moving really, they have to interlock, so we can't move them side to side, really. How about flipping like a mirror image? Well, no, because if we make a mirror image, the piece between the 2 trees will be above the 2 single bloom flowers. We need to figure out something to put in between. How about rotating it? How about if we took a point right in the center there and we turned it 180 degrees counterclockwise? Just imagine doing that. Here's a little visual aid to help you, okay? Well, if we did that, if we rotated the pieces of fence that way, the piece between the 2 trees would then line up with the piece between the 2 single bloom flowers. So yeah, I think that's what we want to do, which means that the dotted line between the double bloom flower and the tree there would probably be matched up with a piece of fence just to the right of the top single bloom flower. And next to it would be a horizontal piece that would correspond to the piece dividing the 2 single bloom flowers. Something like this. Well, now we've almost got the fence finished. At least a fence finished. The obvious place is to connect this one dotted line with the piece dividing the 2 double bloom flowers. And now that looks good. Let's go ahead and change the dotted lines to solid lines. Okay, have we done what the problem asked? Yes. Look at the top piece. Look at the bottom piece. If you rotate one, you get the other. All right, they're the same size, they're the same shape, and they divide up the plants the way we're supposed to. Now, you could probably come up with other solutions, but I think this is the simplest, and it's the one that makes the most sense. All right, now, as we always like to do, let's step back and think about this from a problem-solving standpoint. What did we just do? Well, first, we tried to find places where we knew there had to be a section of fence. Second, we thought about what it means to be the same size and shape, specifically things like rotating, which is what we did. And third, we combined what we knew about shapes in general and what we knew about this fence in particular to come up with a possible solution. As always, we highly recommend, if you enjoyed this, you check out the other videos on this YouTube channel and go by the blog. Both have the same name, You Do the Math, K through Calculus. And as you have heard 1,000 times, if you enjoy what you see, please like and subscribe. Thank you.